Hello everyone, it's February the 6th. Alright, yesterday, another contest. I wasn't able to do it from the start, so I did it maybe an hour into it and finished 3. Not too bad. The last one, I thought about it, I wasn't able to figure something out immediately, so I just ditched it, which is fine. So we're gonna take a look at this one again, which is the minimum time to remove all cards. So I'm going to do this one again. I have some ideas. I thought about it last night when I was going to sleep, and then halfway through my train of thought, I fell asleep. And then I thought about it again today when I was taking a nap, and halfway through that, I fell asleep. But I have a general idea. It's just not fully baked. So I'll solve the first one today, which is remove duplicates from sorted array. Okay, that's a very early on problem. Given an array, in non-decreasing order, so it's okay. Remove some duplicates in place such that each unique element appear at most twice. The relative order of the elements should be kept the same. Remove some duplicates in place such that each unique element appears at most twice. Interesting. Since it is impossible to change the length of the array, you must instead have the results be placed in the first part of the array. More formally, if there are k elements, after removing the duplicate, then the first k elements should hold the final result. It does not matter what you leave behind beyond the first k elements. Return k after placing the final result in the first k slots. Okay. Do not allocate extra space for another array. You must do this by modifying the input array in place with O1 extra. Okay, let's just do this. Judge will test our solution. I don't remember reading this one in the past. Input array, the expected answer. K equals this, and then okay, I see what it does. All right. Output 5. So we don't output nums because it's changed in place. The function return k equals 5 with the first 5 elements being 1, 1, 2, 3. So it does not matter what you leave beyond. Okay. 3 times 10 to the 4th. What's your idea? If we want to do it in place, are we talking about moving things around? Like, if I go boom, 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 we get more. Then we put this value to the end, and we remove this one front. And then we go. Basically, after we put this to the, we put this to the end. Now we take this out, right? Temporary, and then this position is open. And then we move this, and then we keep going. We just move this, and move this, so we find another one. And that's not O1, it's extra space. I'm gonna draw it. Maybe it'll give me more intuition. 1, 1, 1, 2, 2, 3, right? So we have 1. We'll read another one. That's good, and we'll read another one. So this is problematic. So we swap, okay? And then we read a 2. That's good. So we keep swap. 3, that's good, so we swap. Okay, so what if I have multiple? Right? Example 2. 0 good, 1, 1, 1, 1, 2, 3, 3, right? So 0, 0 good, 1, 1 good. And this one's bad. And next one is also bad. But when we have bad, we have a consecutive bad, right? Okay, so we have a consecutive, we know in which range is bad. And then what? And then we just swap in. Move forward. swapping, move forward, swap. So it's like a sliding window of bad, right? We just move forward, not move forward, we just replace this. So, and if we encounter another bad, because as we do this, the bad window will keep moving the same rate. And if we move 1, move 2, and then we see is the same thing, then we move the right forward. I think I know. The coding wise might present some issue. We'll see how we code this. So yeah, so it's a sliding window. Keep that in mind. It's a sliding window. Okay, so what we need is we start with low and high, okay? And then as we go forward, right? And with low and high, it's the same. Hold on. Lower high pointing to the range that's bad, right? And now I'm here, right? And I want to swap me with a low, right? Swap me with a low, and after swap, move both forward, right? So initially low and high could be in the same position, and I look at myself, right? If this is equal to the previous one, then it's good. If it's good and I still do the swap, so I swap and move forward, right? And then it's the next thing is the new one. Let's go reset the counter, and we'll swap. How do we swap? We shall swap with myself, right? We should swap with myself. And I'll move forward, swap with myself, and we'll count 1, we'll count 2, and then basically we swap with myself, and then after swap, low plus equal 1, high plus equal 1. Okay, so I move to here, and it's still the same. Now count equals 3, so that's a bad one. If it's a bad, high move forward, low doesn't change. Right? It's still bad, high move forward until it's not bad. And okay, so I think I need a low and a high. Both starts with 1 on 1. Okay, and what's num size? 1. Okay, and then we just say for I and enumerate nums. Okay, so if it's enumerate nums, we say, oh, actually no. For I in range, let's say from 1 to len nums. Okay, and then we need a count. Okay, so we need a count with 1, and then we say if nums I is not equal to nums I minus 1. That's a good case, right? Not equal to nums I minus 1, or it's equal to, now it would be easier to handle this. If it's not equal to, then we just swap and move forward. How do we swap? We say nums low, and then nums, first of all, count, we reset, and nums low, nums I equals nums I, nums low, we swap, right? And then low plus equal 1, high plus equal 1. That's it. Else, but elif, so they're equal, but they're equal else, okay? If else, then count plus equal 1. Okay, if count is smaller or equal to 2, so we do the same thing. right? So it's still good. Oh, hold on. If they're equal, yes, we're still, so we allow. Okay, so do the same thing. We're gonna swap and move forward. Else, then not equal. Then we low will stay as it is. High plus equal 1. Okay, high plus equal 1. And keep running this. Keep running this. Once we're done, right? So small if it's 2, but if it's a 3, then we do this. And then we coming back up. Yeah, we keep the count. Keep the count. Count will get bigger and bigger. Doesn't matter. So high, we just keep moving forward. Low will stay at the first position that the bat starts, and until we hit a different, and count will be 0, right? And then low and this will swap. And after swap, everybody move forward. Okay. So once we're done, when will we be done? We keep moving forward. We keep moving forward until, if you look at this, high is always plus equal to 1. And no matter what, high plus equal to 1. So we don't have to do this separately. We can just do it because we don't have to do this. We don't have to have the else. High will always plus equal to 1. So eventually, we'll get out. So we know the size will be high minus low plus 1, right? We want a k. What is k? First k elements. So I have the low, right? So I just need to return 0, 1, 2. Yeah, I just returned low. Okay. Test. We have this. Right. Return shall be 5. This one return shall be 7. I actually want 2 things. I also want this. And this one I want this. So I'm gonna double check. Alright, so this is gonna be nums k answer. There's no result. There is result. There is result. So remove duplicate nums. So result equal to k and nums 1 to k equal to answer. Now we pass. That's interesting. Answer is this. Can we also do k and answer? This one will be result and nums 1, 2, 1. No, I just do nums. Okay. 1, 1, 2, 2, 3, 0, 0, 1. Okay, this one is not right. Let me handle this. This one shall be right. Oh, my bad. It's not. It's this. Okay, first one passed. Second one does not pass. All right, let's see. So initially, I is equal to, but its count is 2. So lower high is 1 and high is 1. So we swap in here, doesn't change. And low go up, high go up. So both point in here. Let's do this one. Both point in here. Next round coming up is not the same. Count equal to 0. And both going here. Next one up, it's equal to, count is 2, so it's fine. So both coming here. Both coming here, right? Both coming here. Now this coming is equal, and then count equals 3. Right? If count is equal to 3, then high move forward, low stay here. So high is here. Next one go. Count is 4. So high goes here. So low is still here, high is here. The next round, I think high is moving too much, isn't it? Both is here, right? And then we move forward, low and high point into this, and it's too much. It's too much. High should not move forward. So low and high shall be positioned. So low doesn't change, but high shouldn't move forward. So else, high does not move forward. Okay, and how about next one? Next one is bad again. Then high needs to move forward. I think is else. High doesn't move. So high, I want high to move forward every single time. Right? But because hold on, current, they're all hitting a low, high, and I. They're both at this position. And it's bad, right? It's bad. I should assign high to the bad position. Right? The next round, high should assign to the bad position. And next round, so high is here. So next round is here. High is always behind. High needs to be behind I. Not like high is with I. So then the regular will be here. And it's not the same. And then I can swap. Right? I swap. And after swap, low move. So after swap going forward, if I don't swap, okay, so that's fine. I think I can just do this. After swap, I do this, right? And then else high, because this is basically say the current one is too big, so high equal to I. Nah, still not right. How? I said if it's bad, so like the current one is bad, right? Current one is bad. High need to move to this position. Right? Count is smaller or equal to 2. Hold on. Let's print count low, high, high. And let's not do this. So count is 3. 0, 1, 2, 3, 4, 5, and both at 5. That is bonkers. Oh, this shall be 1. Count shall be 1. Count shall not be 0. And in this case, do high plus equal to 1? Let me think. So I hit a position, right? And high. So what do you say the high will keep moving, or high will keep moving, right? So they both initialize the same position, and then no matter what happens at the end, high will moving. So next time, low and high and high is the same position, right? And then we move forward, the same position. And then if it's bad, this one's bad. Yeah, I think high will be moving too much. Yeah, I'd rather make high this way. Make me feel. I think if I don't do this, let's say if I say high plus equal 1, I don't think this is right. Ah, this is actually right. How? Because they are all pointing to the same position, right? And then next one, high and the low both in here, because this is more equal to 2. I'll swap, and then low plus equal 1, high plus equal 1 are both pointing to this one, and then I come into point this one as well, and then now count is too big, so high pointed to this, right? The next one, I come here, it's too big, high pointing to this. Now high pointing to this, and then the regular come into here, and then it's bad, and then I swap, and high move forward. Oh, yeah, I think that's right. The only wrong is the initial, the reset of the counter. Okay, let's try run the code. Okay, let's try some test cases. Let's say, I don't know, 1, always a good test case. 1, 2, 3. Okay, how about that? Uh-oh, that we have a problem. Okay, so we have problem. Probably can handle a test case like this. Expected this, I got 1, 1, 2, 2, 2, 3, 3, 3. Okay, so this is an issue. This is a problem. Okay, let's do this. 1, 1, 1, 2, 2, 2, 3, 3, 3. All right. Suppose the answer shall be 6 and 1, 1, 2, 2, 3, 3. I got 8. So 1, 1, 1. Okay, so I'm pointing currently is at this position, and then it's too big. So high pointing to this, low stay at here. And next one coming in, it's not equal, count become 1, and then swap. Okay, so it's 2 and it's 1. Ah, I cannot do that. I see the problem. Ah, okay, so count and pre. We need a pre. Alright, so if this is not equal to pre, if it's not equal to pre, then we do this, else we do this. We have to update the pre. How do we update the pre? If this is not equal to pre, then reset pre equals nums I. Okay. If it's equal to pre, then we don't have to change. There we go. It's one more step. One more step. Okay, so let's try this. Let's use the Okay, lots of this, lots of this. Actually, let's do this. 4, 5, 6, 7, 8. Run it. If this passes, I think it's good. Yep, let's try this. Oh, I've done it 2 times in the past. Yep, not bad. I did so many different solutions. Let's take a look at the last solution. But it's slow, only 27%. This is a win though. Anyway, so this is LeetCode is 80. Anyway, so it's ON 92 27. This is 80, number 80. I voted. So keep a sliding window of bad elements each time a good element is encountered. Swap the beginning of the sliding window with the good element and progress the window's boundary. If a bad element is encountered, only progress the right boundary of the window. One caveat is to use a separate variable to store the previous value, because once the swap is done, the element at nums I minus 1 is no longer the real previous value. I'm not sure if it makes sense. Makes sense to me right now. Okay, let's see. This is my solution. That's not today. That's a while back. Oh my lord. Okay, have I not improved at all? Maybe this is my old solution. Okay, let's take a look. This is my original. Anyway, is it today? I don't think 164, 165. Yeah, fewer test cases back then. Ah, terrible. Okay, let's see. That's my original from the last time. Yep, I think it's the same. I think it's the exact same idea. All right, let's take a look at Pochmann's solution. We're still in 2 point, but we don't need a count. We can check. No, I was to achieve both. Oh, wait. Wait, what? We don't need a count. I have a count. I think this is the pre in my current setup. We can check nums I minus 2 with nums j. J is the current. If this is not is equal, then it's bad. If this n is guaranteed, the max repeating is yes. If they are equal, given that nums is sorted, we can also be sure that nums i-2, which violates the requirement. Okay, so if this is not equal to nums i-2, which is good, right? Then wait, if I smaller than 2, or n is not equal to, oh, it's just moving the left pointer. So when it's good, we move the left pointer. When it's bad, wait, what do we do when it's bad? No, when it's bad, we don't move anything, right? When it's bad, we don't move. It's the same. When it's bad, we don't move anything. When it's good, and when it's good, we want to swap. It's here. When it's good, we swap. When it's good, we swap. So we compare. If it's good, so we swap. And then we move on to the next one. And when it's bad, which means, but we swap. We swap with, okay, we swap. And how do you guarantee i-2 will not be tricked by this? Because it's sorted. But why does it matter here? That's a good question. Why does it matter here? Well, it's matter here because I'm checking in front and then in front, right? So we're checking two values before. It's bad, then I don't do the left, right? The left we don't move, we just move on the right. So if it's bad, so if it's good, then I assign them this with this value. So I assign nums I this value, and I'm not changing. Oh, I'm not. It's not swapping. This is not swap. The problem happens if we swap. This is not swapping. We keep the original. We just put the right thing to the front, and we just go move. Oh, whew. Damn. Yeah, this is not swap. So this is from the solution I obtained from Mr. Pochmann in December. This is December 2020. Wow, that's more than a year ago. So 2020, 12.1.1. The core idea is the same, but the implementation, right? Implementation is smarter. Since the right boundary of the sliding window moves along with the current pointer, these two can be combined as one. Also, instead of swapping, we simply assign nums low with the correct element. It is, we don't have to prepare a separate variable to store tree. Finally, since we are not swapping, the the array maintains its sorted feature, right? It maintains its sorted feature, around nums I, which means we can simply check nums I equal to nums I minus 2 to examine whether there are more than 2 repeats. Okay, so here's where we go. I still want to do low or equal to 0. Okay, then for high and in numerate nums, right? Say if high is smaller than 2, or nums or n is not equal to nums I minus 2, right? So this means it's a good case, good cases. If it's a good case, nums low equal to n, so instead of swapping, just assign to keep array sorted around nums I. And low plus equal 1. And then return low at the end. Alright, something's not right. I think it's smaller equal to. Wait, hold on, no. It is smaller. If smaller than 2 just means high is 0 or high is 1. I just keep going. And high equal to 2. If it's not equal to nums low, so low and move with it, right? It's not equal to, so it's 4 and 5. Huh. Alright, let's see. So both are here, and then I say for high in the numerate nums, high is 0, 1, so low plus equal 1, so it's keep, so now high is here, okay, high equal to 2, and n is not equal to, it's false, so low doesn't move, so low is stay here, right, low stay here. Hold on. Low 0, so high initial 0, right, and then high small initial, so low plus here, now high is here, right, and then low is here, and high is here, and then it's bad. So low stay here, low is here, and move forward, right? So high is here, and then high minus 2 is not equal to, okay? So it's not equal to, then nums low equals n, so this becomes 2, and low plus equal 1, so low moves here, and this is 2. And now high comes here. High minus 2. Wait, this is not right. Hold up. How do I do this? Ooh, hold on. Oh, I didn't understand it right. There's no high, it's only low. And we just move, wait, I minus 2. I is low. Okay. So wherever I am at my current n, if it's not equal to I minus 2, hold up. So the first 2 is fine, right? Plus equal 1, and then we come to this position. And n, okay, is equal to this, right? So we don't do anything. And move forward, n comes here, n is here. And then n is not equal to, that's true. So this one becomes 2. And low comes here, right? And then next thing's here. And this minus 2 is not the same. Oh, that's... No, don't think about a sliding window. This is, the low is the beginning of the bad. That's it. Low is the start of the bad. So if low is the start of the bad, and whatever I am currently at, whatever value it is, if low is the start of the bad, then if I go 2 rounds, and if I am the same, that means I need to keep moving forward. So this one cannot be included. Nah, this is the core idea is actually not quite the same. Not quite the same. Here we see low, not low, then we just shouldn't call it low, right? We should just call it I. Just assign the good element, assign the good element to its correct position. And I plus equal 1, and this is I. That's exactly the same as this one. We use I to represent the beginning of the bad window. As we iterate through n, for each element encountered, we check n equal to nums I minus 2, right? Because I is the start of the bad element. Right? If I is start, and then 2 elements before I, then if n is equal to nums I minus 2, that means n is equal to nums I minus 1 and equal to nums I plus 2, which is a violation. In this case, n is bad, so we should not do anything with it. On the other hand, if n is not equal to nums I minus 2, that means n is a good element, so we put nums, so we do nums this equals n, which is to place a good element in its correct position. This is good. So yeah, over a year, I don't think I improved on this. It's still a very small solution. Yeah, and it's fast. Wait. The hell? Oh, there's no enumerate. Shoot. My bad, there's no enumerate. Just direct, yeah, that's good. I probably should be at 50. 70. It's alright. Alright, so call that. And let's keep working on this one. Okay, so I'm going to turn this off. And we're going to open this. Alright, I didn't even start, but now I'm going to try. It's last week. DSU. What's this? I just want to remove. I remember this one. We remove a letter, and everything, if we remove a letter is the same, then they shall belong to the same thing. Yeah, I always do this, else. Yeah, I remember this one. Anyway, so just try. If it doesn't work, I'll try later. Alright, so the ideal is we definitely have to remove the front and remove the back. So those are like no question. So we remove those. So now we end up with this setup. So start with 0, end with 0, a bunch of 1 in the middle. So what's the least cost to remove all the 1s? So the ideal is if I have these 1s, so these 1 can never be removed directly, right? Either we have to remove the zeros at the front to expose this to remove at 1 cost 1, or we can remove it as in the middle, so that's cost 2. So my ideal is if we have a bunch of this 1 in the middle, if I remove 1 in the middle, right, which is anywhere, it takes 2 units time, so we remove at 2 units time. And then for the next 1 in the middle, it's always worse, right? If we try to remove it, that one by taking everything away from the front, then that always costs more because we have the 2 and everything else, right? And if I just remove 1 by 1, that just 1 costs 1. So it's always a worse decision to first remove something, right? First remove something by in the middle and then remove from the front. That's a worse decision. So the only possibility, like as long as if we remove one of them as in the middle, then all of them should be removed as in the middle. Therefore, the choices are we remove everything as the middle, and we remove the first one as 1 by 1, and then remove the rest as the middle, or remove the first 2 as 1 by 1, and remove the rest as the middle. So that's the strategy. And of course, we can do on both sides. So when we obtain this, we need to split in half, right? Split in half, it's even, that's easy. If it's odd, we can put the middle part to the left, to the right, doesn't really matter. So all of these has to go through the same procedure. So again, I haven't thought about this too carefully, but what we can do is we can go, let's say, I equals 0, right? And I say while si is equal to 1, I plus equal 1. I'm going to do I and j. So in front and back, it land as minus 1. Okay. Ooh, I just realized something. What if it's all ones? Ah, madre mia, if it's all ones, while I smaller, okay, so to prevent this from happening, let's do this. That's n minus 1, right? And while I is smaller than n and this, blah, 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 and then while j has to be larger, if they meet each other in the middle, they shouldn't meet each other in the middle. So j has to be larger than n, not larger than I, right? And as j is equal to 1, j minus equal 1, right? And once we're done with this, we can say res plus equal to, how many steps? I plus, so I will be pointing to the first 0, and j will be pointing to the first 0 as well. So j is going to be, shouldn't be, n minus 1 minus j, right? Let me think, it's n minus 1 is n minus 2. Right? N minus 1 minus n minus 2 is 1, but now it's n minus 3, so it's just n minus 1 minus j. Yeah, so that is the start. And then we have I to j, right? We have I to j, and then we need to split them in half. Well, another reason to split them in half is because the ones on the left half, you don't want to remove it from the right, because it's always going to be worse, right? So we split in half. Okay, so we say mid is equal to I plus j divided by 2. So now we have a mid. So on the left half, what we're going to do is, what would be the best way to do this? What we can do is we can obtain all the indices of I. Okay? We obtain all the indices. Or we can just read through, obtain all the indices of I. So the original will be all of them times 2, right? And then we remove the first and then plus whatever thing we need to do. And then we remove the first 2 and plus that. Remove the first 3 and then plus that. Okay, so how do we do this? For k, right? So we say left min equals 0. We don't know, right? And then we say what do we say? So we either mark it as plus 2 or plus that, right? And then the next one will be plus this. Oh, let me write it out. So what we're looking for is either plus 2 or plus, let's say plus k. The next one's plus 2 times this and then plus k. Right, and next one plus 2 times whatever and then plus k. But actually it's plus k and then plus the remaining. It's just up to this position we have that much. Yeah, this is ignoring the end, so I shall obtain the entire thing, and which is a minus k plus this, minus 2 this plus this, and I want to find the smallest. Okay, so what we need to do is left min and 1 indices, right? Yeah, I need to say for k in range from I to mid plus 1, right? We're going to do I to mid, and then if sk is equal to this, if sk is equal to this, then we say left min plus equal to 2, because initially we say all removed from the middle, and 1 indices dot append k. Right, so once we run all this, we're done. Then we're gonna go through it one by one. Right, how do we go through this one by one? We are going to say for index in 1 indices. So these are the actual index, which means if index 1, we take 1 unit. If index 2, 1, we take 2 units. 0 take 1 unit. So it's going to be index plus 1. So we say left min equals minimum left min minus, right? Minus what? Minus, so I actually have to have of index, also need a count. Okay, so we're going to count and this enumerate. Okay, so we just say we want to take 1 out, and then we do this, right? So I'm going to say count plus 1, that's the number, right? And times 2, which means we don't remove it from the middle, but we remove it from index plus 1. Okay, so that's a left min. And we're going to do the same thing for right min. Okay, so we're going to do the same thing for right min. And this is going to be from, now that you think about it, maybe it'll be easier to use a negative. Yeah, probably not. Okay, so this is just going to be from j to mid minus 1. Right, and if this is this, then right min plus 2 minus stop and k. Okay, so blah blah blah, we do everything, and then these indices are from right to left. Right, they're from right to left. Also count and this, that's fine. And then this all going to be right min, right min. Okay, this is fine. This needs to change, right? This needs to change index. So this has to be n minus index, right? That's n minus 1, n minus, and then we don't have to plus 1. So this has to be n minus index. And then at the end, we're going to return res plus left min plus right min. Not sure. If it's not right, then we're gonna think about it again and do it tonight. 100, 101. Okay, this is 5. And this is 0010. This is 2, right? And I have a couple more. I'm gonna try. Let's say 11100. Yeah, these are not like 01 00000 10. Right? That should be 4. What else? What else are you thinking? Well, I'm thinking 0111 0000010. Something like this. If this on the left, we should just take 1, 2, 3, 4, 5, 6. But it's on the right. No, you know what? This has to be buried inside. I should bury it in here. That should still be 4, right? And if this one was buried inside, that should still be 6. Because that's 1, 2, 3. Not 1, 2, 3, 4. And then 5, 6. Okay. So S time S int object is not iterable. Wait, what? Oh, there should be left mean on this. This also should be a right mean on this. Oh, I got 5. How do you get this with 5? That's interesting. I could be wrong. I thought it's 6. Okay, let's put in my 2 test cases. I have this, and I have 0, 1, 0, 0, 0, 1, 0, 0, 0. Maybe it is 5. It is 6. Output is 5. That is interesting. Okay, it's fine. Take a closer look. Alright, so we're going to do the look before we start. Now I'm going to do this. Print res left mean and right mean. Right mean is 2, that's true. Left mean is not right. I see. I and J is not right. No, ing is correct. Hold on. Let's see, ing 0 and 14. Ing is correct, right? Ing is correct. But the left is 3. How do you figure left is 3? So from 0 to the middle, whatever the middle is, if this is this, left plus equal to 2. But the first one is not, the second one is. So let's print out the 1 indices here. 0, 1, 2, 3. That's correct. So if we do this and then we do left and mean, that should be 6. That's correct. And then each one, this one will be minus count. So it will be minus 2, right? So it will be 4 and plus this index. Oh, I think I know why. No, I don't know why. Index is 1. Should be plus 2, right? Hold on. Let's do this print. This thing. Index count. Index this. And then let's not do this. Okay. So it goes to 3. So initially it's 6, right? The first time index is 0, index is 1, and this is 6, which means there's no change. So, which means if we do 2, and then 2, 2, and that's 6, right? There's no change. Next round, index is 1. Oh, the left min shall not change. I see. Okay, so, madre mia. So this has to be 2 values. Oh my god. I don't like it. I don't like this. Let's do it this way. Right, and then we don't need this. We just acquire this, and this will be 2 times len y indices, and every time it's going to be 2 times len this. So the same thing with the right. Don't do this because this has to stay the same throughout the entire time. Right, this will be the right min, and this will be the same. And if we do this, that's good. And these shall be the same. Okay. Let's handle this. Come on. Okay. Let's see. Wrong answer. Ooh. Okay. All right. I just finished right now and pick it up tonight. Adios.